back again in review mode still. Number 9 from our review paper that we were working on last night. Compare the x components at point A and the x components at point B. So what would you say about that? Emily, number 3.
The x components are equal.
Right. The x components at point A and point B are the same everywhere, right? So definitely they're equal. All right, Zach, what about the comparing the y components at A and B?
They are equal except for the fact that one is negative, one
Right,
positive.
so if I was going to draw the vector here, the x components would be the same. That's the orange ones, but the blue components, the y one, would be positive and negative. Same value, opposite direction. Did I have another question there? Compare the velocity. So that's not the x or y. So if you knew the velocity, I'll go to green here. If we knew this value, would it compare to this value?
It's positive slope and negative slope.
Yeah, it's the same magnitude as well.
So
Very good.
So it's I put
Same but
like
opposite sides.
Pardon?
Just the same but opposite sides.
It's not opposite though, because say this is 15, this is also 15, it's just at a different angle.
Okay.
So if this is going at 30, this is going at negative 30, if you allow me to use negative angles. But you don't have to know about that. If you had that in math class, good. But the actual velocity, the magnitude is going to be the same.
Okay.
All right. All right, so let's do, if you got that, you can get 3 bingos on that. If you got the x part, B1. If you got the y part,
Wait, what was
and
the,
4,
what was the X part?
B1. And if you got the final, the other one, the third part, it's B5. B5. All right,
No.
number 10. If air resistance were included in the range of calculations, how would the range change? So, the thing, is it going to go up or down? What do you think about that one? Where are we? Hunter?
the range would decrease.
The range would decrease because you're going to have all those bumping molecules slowing it down. So if you put decrease, you were right, and you can cross out N1.
Miss Powell, what was number 9 again? The final answer?
Number 9
Velocity of A was positive and velocity of B is negative.
for the y components. For the x components, they're the same throughout. Remember how it works? So we have it still
Yeah.
drawn up here. The x components, the velocity is the same throughout. The y components are the same,
No, for
except the
compare the velocities of both of them.
and the third part, the velocity is the same.
Alright.
It's going to be at a different angle, but it will be exactly the same. If it's on the same, if they're right across from one another on the parabola.
Except that they're going to be negative.
It won't be quite in y. But what about this vector, Zach? Just this.
Oh, the vector will be the same. But it'll be negative and positive.
Well, not exactly. Because say this one was at 30 degrees.
Uh-huh.
This one would be at negative 30 degrees. The actual velocity will not be a negative velocity.
Okay.
So,
Oh, yeah, because it's coming down.
Right.
So it doesn't change
So
the
they're-
velocity.
yeah,
Okay.
So they're equal?
yeah.
So the x components are equal, the y components are...
They're the equal, but in the opposite direction. See how it looks here? The blue one is going up, and over here the blue one is going down, but it's the same magnitude. All right. Number 11, what would happen to the range using the range equation if the gravitational constant was cut in half? We were practicing some of those the other day.
The range would increase.
By,
2.
you have to tell me by what factor.
By 2.
Yep. All right, let's see if you got what Brian got. So if you have a G here and you go in and you divide it by 2, that means you have to do that over here. But look, that 2 is in the denominator of the denominator. So when you take a denominator and you flip it and multiply, it has the same effect as multiplying that side by 2. 5 minutes. All right. Describe the situation in which the range. Oh yes, that's right.
That's the most important thing.
I won. Remember I said that the other day. Everyone went bingo, bingo, bingo. Not today. All right. Describe the situation. Oh, write down what would happen to the range if the velocity was tripled. So we did those yesterday. Emily.
It would increase by a factor of 9.
Right, so you go in and the 3 hugs the V sub O. Whoops. And so that is the equivalent of putting a 9 over there. So you would say the range increases by a factor of 9, or the range is multiplied by 9. Describe the situation in which the range equation can be used.
2 in a row. It has to be a parabolic motion and the starting point and the
The
end point
height
have to be the same
initial and
plane.
the height final.
That's
equal.
very good, you got it. We talked about it already today. And every day. In parabolic motion, what is the only force acting on the y component? Emily, number 3.
Gravity.
Gravity. What force acts on the x component? Emily, number 2.
Gravity.
No, the initial.
Initial velocity.
What force? Velocity is not a
Whatever.
force.
Whatever.
Air
it
resistance.
Nothing.
Oh,
Yeah.
that was a trick question.
Oh, wait, so it's nothing?
Nothing, no force is acting
Could
on
we
the
put-
x component.
could we
If it
put air
was
resistance?
a force, you'll learn later. Force always causes acceleration. Since there is
Wait,
none, we
can we
know
put-
there's no force
can we
on
put
the
it-
x component.
Can we put air resistance?
Yes,
Okay.
picky.
So we should have
What
like
is this
4
for?
now, right?
All right, this one, did we do number 12?
No,
We
wait,
need
All right.
4
We
bingos
need-
first.
we need-
Four bingos, just do,
We
yeah,
need
4
one
bingos.
for
Number
velocity
12.
triple.
Oh, we didn't even do that one. All right, for second part of number 11, if you said that if you tripled the velocity, you got 9 times the range, you can cross out G1.
Bingo.
Yay!
Ah.
All right, and keep going. And on number 12, if you said it starts at the same height and ends at the same height, you can cross out I4.
Bingo.
Cool. Another way? Another bingo, another way? Well, you have the magic card. All right, in parabolic motion, what is affecting the y component if you said gravity? And 2. And if you said nothing except air resistance, you can say 04.
No, I needed 04.
Then you didn't get it.
Wait, did we do
Bummer.
one? Did we do
The
one
ball
for
reaches its
open?
max height in 2.2 seconds. How long does it take the ball to land, assuming we have parabolic motion? Just take that number and
Double it.
double it. 4.4. You may cross out
04.
and 3.
Bingo.
I would have won if I got it.
Fire over there.
The dart is tossed
Yeah,
at the
I
target
can-
following parabolic motion. If its final speed is 28 meters per second just before it hits the target, what is its initial speed?
28 meters per second.
28. 28.
Oh, yeah.
Yeah, it's 28.
Oh, yeah.
That's okay.
B3.
Bingo.
That's it. We're done.
We're done.
9 minutes.
Did we forget to do
Bye.
one for-
Over and out. Hope that this helps you. It is a good review.